Good morning. Welcome to the session. See, in the last class, we discussed about two different terms. One is order of a reaction, other one is molecularity of a reaction. Let us recall it once again. Now, what is order? See, order of a chemical reaction, it is nothing but sum of powers of concentrations of the reactants in a rate law expression. Sum of what? Powers of concentrations of the reactants in a rate law expression, it is called as order. See, order, it is always obtained from the experimental data. It cannot be obtained from the balanced chemical equation. Second point, order of a reaction can be either 0 or whole number or even a fraction also, Order of a reaction, it is applicable for both elementary as well as complex reaction. We discussed about one more term, that is molecularity of a reaction. Now, what is molecularity? Molecularity means number of reacting species, or number of atoms, or number of molecules, or number of ions participating in an elementary reaction which must collide simultaneously in order to bring about a chemical reaction. So those number of molecules, or those number of atoms, or those number of ions participating in an elementary reaction, it is called as what? It is called as molecularity of a reaction. Remember, molecularity for a given reaction, it is always a whole number. It cannot be equal to 0 or it cannot be a fraction also. One more thing you have to remember, that is molecularity, it is always obtained from what? From the balanced chemical equation. What about order? Order, it is always obtained from the experimental data, whereas molecularity, it is obtained from the balanced chemical equation. One more, molecularity, it is applicable only for elementary reaction. It is applicable for only elementary reaction. It is not applicable for complex reactions. Now, today we are going to discuss the unit of rate constant for zero order, first order and second order reaction. We are going to discuss what? Units of rate constant for zero order, first order and second order reaction. Okay, let us derive the expression first. Let us consider a general reaction. General reaction, that is A and B reacting to produce the products C and D. Small letter A, small letter B, small letter C and small letter D represents stoichiometric coefficients of the reactants A and B and products C and D. Now, rate law for this reaction can be written like this. See, rate, it is equal to K into concentrations of the reactant, that is concentration of the reactant A into concentration of the reactant B. Their powers, I will take it as X and Y. They are what? They are orders with respect to reactant A and reactant B. We don't know the values of X and Y because it is obtained from the experimental data. So, let the rate equation be rate equal to K into concentration of A power X, concentration of B power Y. Now, what we have to take is, we have to take rate constant K, or rate constant K, it is equal to, expression becomes what? Rate divided by concentration of A power X into concentration of B power Y. So, rate constant K, it is equal to rate divided by, it is equal to what? Rate divided by concentration of A power X into concentration of B power Y. See, this is concentration term, this is also concentration term. It is just like A to the power X into A to the power Y, it is equal to what? A to the power X plus Y. So, similarly, we can write concentration term to the power X into concentration term to the power Y. What I can write? So K it is equal to rate divided by concentration term. It is not concentration term to the power x plus y. To the power of x plus y. Now what is x and what is y? X it is the order with respect to reactant A. Y it is the order with respect to reactant B. Now x plus y can be taken as n. N means overall order of this reaction. So x plus y, let it be equal to n. So K equal to rate divided by concentration term power it is n. Concentration term power it is what? Power it is n. Or K it is equal to, what is rate? Definition of rate, change in concentration with respect to time. So rate it is equal to concentration, rate can be written as concentration divided by time into this one denominator, that is 1 by concentration term power it is n. Concentration term power it is n. This is concentration term power it is 1. This is concentration term power it is n. So our K it is equal to concentration term to the power a to the power x divided by a to the power y. It is equal to what? A to the power x minus y. So concentration term to the power 1 minus n into 1 by time, or it is what? It is time inverse, time to the power minus 1. So concentration term power 1 minus n, time power minus 1. Now we know the units of concentration and time, correct? Concentration it is expressed in terms of mole per liter. Concentration it is expressed in terms of what? Mole per liter. So mole per liter power 1 minus n, time it is expressed in terms of second. So second power minus 1. Second power minus 1. So generally we can write rate constant K, it is equal to what? Mole per liter power 1 minus n, second power minus 1. Now let us check the units of rate constant for 0 order, first order and second order reaction by substituting the value of n. N means order, correct? So n, if I substitute it equal to 0, then it becomes 0 order. If I take n as 1, then it is first order. If I take n as 2, then it is second order reaction. We shall check the units for 0 order, first order and second order reaction. See, first one, for a 0 order reaction. For what? For a 0 order reaction, rate constant K, it is equal to mole per liter power 1 minus n, second power minus 1, correct? Here n it is equal to 0 because 0 order reaction. So it is equal to mole per liter power 1 minus 0, second power minus 1. 1 minus 0, it is equal to how much? It is equal to 1, or it is equal to mole per liter per second. So unit of rate constant K for a 0 order reaction, it is mole per liter per second. Similarly, for a first order reaction, n value it is equal to 1. N value it is equal to what? It is equal to 1. So what we can write? K it is equal to mole per liter power 1 minus n, that is 1 minus 1 per second, correct? So 1 minus 1 is 0. Any term to the power 0 means it is 1 only. So mole per liter power 0 means 1. Mole per liter power 1 minus 1, it is equal to 1. So K it is equal to what? It is equal to second inverse. Unit of rate constant for a first order reaction, it is what? It is second inverse. Let us check the unit for second order reaction. For a second order reaction, N it is equal to, N value it is equal to how much? It is equal to 2, or K it is equal to mole per liter power 1 minus 2 per second, 1 minus 2 per second, or it is equal to mole per liter power minus 1 per second. Minus 1 means inverse, so it is equal to liter per mole per second, liter per mole per second, or I can write mole inverse liter per second, mole inverse liter per second. So unit of rate constant for a zero order reaction, it is mole per liter per second, mole per liter per second. For a first order reaction, it is second inverse. It is what? It is second inverse. For a second order reaction, unit of K is, unit of K, that is rate constant K, it is liter per mole per second, or it is mole inverse liter per second. Hope it is clear. Okay, I'll give you one problem. So first one, identify the reaction order. Identify the reaction order from the following rate constant values. From the following rate constant values. In that, A 2.5 into 10 to the power minus 2 liter per mole per second. Second one, 3.4 into 10 to the power minus 5 per second. Third one, 1.8 into 10 to the power minus 3 mole per liter per second. Read the question properly. What they have asked, we have to identify the reaction order from the K values. By using what? By using K values, we have to identify the reaction order. See, first one, it is 2.5 into what? Into 10 to the power minus 2. We can see the unit here. It is what? It is liter per mole per second. Liter per mole per second. What is this? Unit of rate constant for a second order reaction. Unit of rate constant for what? For a second order reaction. So answer, it is second order. Check the second one. See, 3.4 into 10 to the power minus 5 per second. See, per second, it is the unit for first order reaction. So answer, it is first order. Answer, it is what? First order. Third one, 1.8 into 10 to the power minus 3 mole per liter per second. Mole per liter per second. This is the unit of rate constant for a zero order reaction. So answer, it is zero order. So first one, it is second order reaction. Second one, first order reaction. Third one, it is zero order reaction. Next topic, we shall consider zero order reactions. Zero order reactions. Now what are zero order reactions? Say zero order reaction means a chemical reaction. Zero order reaction, it is a chemical reaction in which reaction rate, it is directly proportional to concentration of the reactant, power it is 0, power it is not 0. So what is zero order reaction? It is a chemical reaction in which reaction rate, it is directly proportional to zeroth power, directly proportional to zeroth power of concentration of the reactant, zeroth power of concentration of the reactant. Such a reaction, it is called zero order reaction. Concentration of the reactant power 0 means what? It is always 1. Or in other words, reaction rate, it is what? It is independent. Reaction rate, it is what? Independent of concentration of the reactant. So rate is what? Rate is directly proportional to zero power, or it is zeroth power of the concentration of the reactant, zeroth power of the concentration of the reactant, or rate, reaction rate is independent of, reaction rate is independent of concentration of the reactant. Reaction rate is independent of the concentration of the reactant. So in a given reaction, if the reaction rate, if it does not change on varying the molar concentration, usually on varying the concentration, rate also varies. Suppose on varying the molar concentration, if the reaction rate remains constant, we are varying what? We are varying the concentration of the reactant, or we are varying the amount of the reactant. On varying the concentration of the reactant, suppose reaction rate, if it remains as it is, then that reaction, it is considered as what? Zero order reaction. So zero order reaction means reaction rate which is independent of concentration of the reactant. Reaction rate, it is what? Independent of concentration of the reactant. Such a reaction, it is called zero order reaction. Example for zero order reaction. Example for what? Example for zero order reaction. For example, decomposition. Decomposition of what? Gaseous ammonia on a hot platinum surface at high pressure. Example for zero order reaction, decomposition. Decomposition of what? Gaseous ammonia on a hot platinum surface, or on the catalyst surface at what? At a high pressure. We can write the equation for this. Ammonia, that is NH3. Ammonia, it is a gas at a high temperature, that is around 1130 Kelvin. Catalyst, it is platinum, hot platinum catalyst surface. Reaction occurring on the hot platinum catalyst surface. Products obtained are, one is dinitrogen, other one is hydrogen, H2, N2 and H2. Since two atoms of nitrogen are present, so we have tried 2 here. So 2 into 3, it becomes 6 atoms of hydrogen. So this is 3H2. So 2NH3 gives what? N2 plus 3H2. This reaction, it occurs on the surface of what? Surface of platinum at a high temperature, that is 1130 Kelvin. So rate law for this reaction can be written like this. So rate it is equal to K into concentration of the reactant, which is the reactant here, that is ammonia. Concentration of ammonia, power it is 0. Why it is 0? See, rate law it is expressed by using what? By using the experimental data, correct? Or it is predicted by looking at the experimental values. So rate it is equal to K into NH3, power it is 0. Why it is 0? Because on varying the concentration of ammonia, rate of the reaction remains as it is. Rate of the reaction remains as it is. So rate will not change on altering or on changing the concentration of ammonia. So its power it is 0. So rate equal to K into NH3 power 0. Don't write 2. 2 it is present in the balanced equation. Rate law cannot be written by looking at the balanced equation. Rate law it is always obtained from the experimental data. So rate it is equal to K into NH3 power 0. Therefore, order of the reaction it is equal to 0. Order it is equal to what? Order it is equal to 0. Understood? Next, so we will derive integrated rate equation. Let us derive integrated rate equation for a zero order reaction. For what? For a zero order reaction. We are deriving integrated rate equation for a zero order reaction. This is very important question for the annual exam. This derivation you have to study it properly. So important question. Derive the integrated rate equation for a zero order reaction. Let us derive. Let us consider a reaction, that is reactant R producing products. Reactant are producing the product P. Okay. So rate law, since it is a zero order reaction, I can write rate equal to rate. It is equal to, what is rate? Change in the concentration of the reactant. Change in the concentration of the reactant with respect to time. That is minus dr by dt. Minus what? Minus dr by dt. It is equal to K into concentration of the reactant. See, in rate law what we are going to write? We are going to write a rate and molar concentration, correct? Rate it is equal to minus dr by dt. Concentration it is what? Concentration of the reactant, that is R. Since it is zero order, power it is 0. Power it is 0. Correct? So rate it is equal to K into concentration term to the power 0. Concentration term to the power 0. We know that any term to the power 0 means what? It is 1. So minus dr by dt. Minus what? Minus dr by dt. It is equal to K into R power 0. R power 0 means what? It is 1. Any term to the power 0 means 1. So it is equal to K. Cross multiply. So minus dr it is equal to K into dt. Minus dr it is equal to K into dt. That is all cross multiply. Or dr it is equal to minus K dt. It is equal to what? Minus K dt. dr equal to minus K dt. Let us integrate on both the sides. That is integral of dr it is equal to K. It is a constant. Constant cannot be integrated. Let us take it outside. Minus K integral of dt. Minus K into what? Into integral of dt. See, this is integral side. What is d? Differentiation. Differentiation and integration, they are inverse to one another. They are what? Inverse to one another. So they will cancel out. So integral of dr, Differentiation integration cancels out. Integral of dr it is equal to what? It is equal to r. Integral of dr it is what? It is r. Why it is r? Differentiation and integration, they are inverse to one another. So it is r. It is equal to minus k integral of dt, it is t. Integral of dt it is what? It is t. So r it is equal to minus kt plus we have to add a constant, that is I, where I it is called integral constant. I it is called as what? Integral constant. Okay, so r it is equal to minus kt plus what? Plus I, where I it is what? I it is integral constant. Let us find the value of phi. See, to find the value of phi. In order to find the value of phi, let us use the initial condition, that is when t equal to 0, when t equal to 0, that is when the initial stage or at the beginning, when t equal to 0, concentration of the reactant, what I can write? Concentration of the reactant at a time t equal to 0. So what I will write? R it is equal to R naught. R it is equal to what? R it is equal to R naught. When t equal to 0, R it is equal to R naught. Let us name this equation as 1. Substitute these values in equation 1. T equal to 0, R equal to R naught. These values I have to substitute it in equation 1. So in the place of R, I have to write R naught, it is equal to minus k into t. T value it is 0 plus I. Plus what? Plus I. So R naught, it is equal to k into 0, it is 0 only, correct? K into 0 it is what? It is 0. So it is equal to what? It is equal to I. We got the value of phi. So value of phi it is what? Value of phi it is R naught. Value of phi it is what? R naught. Again, substitute the value of phi in equation 1. That is R it is equal to minus kt plus I. What is I? I it is equal to R naught. I it is equal to what? It is equal to R naught. So R it is equal to minus kt plus what? Plus R naught. Or take this minus kt to the left hand side. So it becomes plus kt. It is equal to R naught. It is already on the right hand side, R naught. Bring this R to the right hand side. So it is minus R plus kt, it is equal to R naught minus R, or k it is equal to, it is k into t. When I take this t to the right hand side, it becomes 1 by t, correct? 1 by t into R naught minus R. R naught minus R. Or I can write k it is equal to R naught minus R whole divided by t. R naught minus R whole divided by t. See, this is the integrated rate equation for a zero order reaction. Integrated rate equation for what? For a zero order reaction. Let us repeat once again. See, we have to consider a reaction, general reaction, that is reactant R producing product P. Write the rate law for this reaction. So rate it is equal to, what is the rate? Change in concentration with respect to time. So that is minus dr by dt. It is equal to k into concentration term, concentration of the reactant term, power it is what? Power it is 0, since it is zero order reaction. So any term to the power 0 means it is 1. So equation reduces to minus dr, minus what? Minus dr by dt. It is equal to k. It is equal to what? It is equal to k. Cross multiply minus dr. It is equal to what? It is equal to k into dt. K into dt. On integrating this equation, or plus dr equal to minus k dt. Integrated. On integration, that is the integral of dr, it is equal to k, it is a constant, so it is taken outside, minus k integral of dt. Integral of what? Dt. So differentiation and integration, they are inverse to one another. So they will cancel out. So dr integral value it is what? It is r. Dr integral value it is r. Integral of dt it is t. It is what? It is t. So r it is equal to minus k into t plus I. What is I? I it is integral constant. I it is what? Integral constant. Next we have to calculate the value of I, that is integral constant. So to find the value of I, so to find the value of I, I will take the initial condition, that is when t equal to 0, that is in the beginning, concentration of the reactant can be taken as what? Can be taken as R0, R0 or it is R0, R0 or it is what? R0. Substituting these values in what? In equation 1. Substituting these values in equation 1. So in the place of R we have to write R0, in the place of t we have to write 0 plus what? Plus I. So we got the value of I. So I it is equal to R0. Again substitute the value of I again in what? In equation 1 only. In what? In equation 1. So R it is equal to minus kt plus what? Plus R0, or plus kt it is equal to R0 minus R, or k it is equal to R0 minus R by what? By t. So this is what? This is the integrated rate equation for a zero order reaction. Thank you.